Now let's look at frames and see how we can check for their determinants. Now with frames, what we are going to do is use what we call a method of sections. Now you see how this element of the frame form this sort of loops around, how it loops and forms this box here. We want to cut that open. Now for frames, we use this method of sections, and we're gonna cut open these loops so that it is no longer some sort of box like this. Now this loop, we are going to cut it here, and we are going to cut it here. We can't just cut it on one side. We gotta cut them so that they can separate. And we are also going to cut it this loop, and we're going to cut this loop and look at the resulting internal forces. Now let's quickly draw this first part. Now we had, if we cut it, we are left with a structure that looks like this. Now a more idealized structure, it will be like this. This is this member 1. Now we now treat the parts that we cut as our parts, now, which means that they will represent n, which is the number of parts. Now this one in the middle also, which looks like an I, it looks like this, will be our part number 2. And then the third part on this side, that looks like this, this part will be part number 3. A more idealized structure will look like this, just the opposite of the other one. Now not only do we want to know the number of parts, which in this case is equal to 3, because we have this part number 1, the part in the middle, and part on the right. We want to know the number of unknown forces, which is R. Now how do we do that? We look at all the reactions and the internal forces that comes from cutting up the sections. Now at the support, we have a pin. This is a pin support, and we know that with a pin support we have 2 forces, which will be in there. We'll have a force in the y-axis and a force in the x-axis. Now I can show that here again. This is a force body and a free body. I just want a more idealized so that it is easier to read, and you are not distracted by my beautiful drawing. Now once we cut this section up, we will now be introduced to reactions inside here, and these reactions will be in the x-axis and the y-axis for both members, right? Now since it was a fixed member, meaning that if we try to bend it, will it be able to rotate? No, there will be a moment that will try to fight against the rotation. So we not only just have the y and x reaction, we also have the moment. Remember that when I do it for on the left hand side and I do it on the right hand side, I'm just showing you that they will both have this reaction, but this will be equal because of Newton's third law. So this and this are equal, coming from the same cut, right? Now even here below we have the same. We'll have a y and x, and then we'll have moment, because our cut comes from a fixed member. Now on this side also, it is just the same as where we cut on the left hand side. So we'll have a moment there, a moment there, a moment there, and a moment there. And then we have our reactions, which are in the x and the y, x and the y. Even here, x and the y, x and the y. Now at the end of member 3, there will be some sort of support here, and we can see that here it is supported by a roller support. Now a roller support supports in only one dimension, and in this case it supports in the y axis. Therefore we'll have a reaction in the y. Now let's now count the number of forces. We will have 1, 2, 3 reactions, right? And what about that comes from our method of sections, our cut? We have 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 here. So we'll have 3 times 4, which is 12. Now 12 times 3 is 15. Now our R is equal to 15. Now remember, I only count 3 here because these forces are equal to these forces. So I only count 3. I don't have to count them twice. So we'll have 1, 2, 5, 8, 11, 14, 15. So our R is equal to 15, and we can see that our R is greater than 3 times N. Our N is 3, so that will give us 9. We have 15 greater than 9. Now the degree of determinacy here will be 6. So if your R is greater than 3n, then your structure, you can conclude that it is statically indeterminate. We can't solve it using the equations that we have. Now let's look. Let's say you have frame of a warehouse here, and you have a warehouse that is nice. It's not my best drawing. I'm good at technical drawing, but freehand, disaster. Now since it is a frame and it forms some loops here, we are going to follow the same method of sections. Now in our method of sections, we said that we are going to look at the members that form a loop and then cut that loop open. Now we have a loop here, we have a loop here, we have a loop. We have so many loops, 8 as I'm counting. That means that we are going to cut it here and then cut it also here to detach this member. We are also going to cut it here and cut it here again on the right side of our warehouse. Now we are going to make 8 cuts. Now once we make those 8 cuts, how many parts do we have? What is our N? Now this part will be detached, and you will have a part that looks like this, which is this part that looks like an F. Now that part is part number 1. In the middle here you have a nice looking, looks like an arrow. This member in the middle here will be our member number 2, and then we'll have one here that looks like a Y. This member here will be member number 3, and then we'll have another one that looks like an arrow, which is member number 4, and then we'll have another F on the right hand side, a backward F, which is member number 5. So we have members 1 because we cut here, so we have this member on the side 1, 2 because we cut it on both sides, 3 we cut it on both sides, 4 and 5. So our N will be equal to 5. Now what is our R, which is the number of forces? So now we go look at our parts and see that our parts, how many forces are acting on them that are unknown. Here you can see that this goes into the ground, so all the reactions, all the supports here that go into the ground will be fixed, meaning that here we have a fixed support, fixed support, fixed support, fixed support, and a fixed support. With a fixed support, it has 3 reactions, which is in the x-axis, the y-axis, and it does not allow rotation, so we'll have a moment. Let me use a darker pen. We'll have a moment. Let's do that for all these ones that we know that are fixed. We will have x, y, x, y, x, y, x and y, and because they are all fixed, we know that they all have a moment that will try to resist rotation because they are embedded into the ground, so there will not be any rotation on those supports. Now let's go up here, up at our cuts. Now our cuts are also fixed. This member were fixed and joined with each other, which means that if they are joined and fixed, they will also have x, y, and a moment. Now as I look, I can see that all of them, I cut them and they used to be fixed, so they are going to have the same type of internal reactions. So I will have a moment at all of them. Now that I have all of them, remember, let me number my parts. We have part 1, part 2, part 3, part 4, and part 5, so that you do not lose me. So we'll have now that we have drawn all our forces, we now have to highlight the fact that member 1 is attached to member 2. So the forces that I'm going to count here, I'm only going to count this one once because it is the same as this one, because it is this part. So I separated them here. Here also they will do the same, they will do the same, they will do the same. I'm not going to count 6 forces, I'm only going to count 3, because if I count here and here, I will be counting the same force twice. Here also they are connected to this part, so I'm only going to count this one once and not count this one. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and 39. Remember, I don't have to count these ones because I already counted here. So our R is equal to 39. Now let's compare our R to 3n. Now our n is equal to 5 because we have 5 parts, which gives us 15, while our R is equal to 30. Now we can see that our R is greater than 3n. We have more unknown forces compared to the number of equations we have to solve them. So our structure is statically indeterminate. To what degree? 30 minus 15 is equal to 15. So it's statically indeterminate to a 15th degree. So we need 15 more equations to solve them. And that's how you find determinacy of frames. Now the examples I did here, both my examples were statically indeterminate. That's a coincidence. Some frames will be statically determinate, and I wanted I'm glad that I did the ones that are indeterminate, so that you not always get and think that they are always determinate. See you on the next video.